it's quite useful to know some properties of even and odd signals that help us in manipulating these signals. So let's begin by looking at a few simple properties. The first property here says that the sum or difference of two even signals is another even signal. Well, to see why this may be true, let's say we have xe1 and xe2 or two even signals, and we form a third signal by adding these two signals. Okay, then we can verify that xe3 is even, because if I compute e3 of negative t, I'm going to get xe1 of negative t plus xe2 of negative t. But each one of these are equal. So that means this has to be the same as this, and so xe3 is also even. In the same way, you can verify the difference of even signals is even, sum of odd signals is odd, and difference of odd signals is odd. Okay, so how about the sum of an even signal and an odd signal, or the difference between an even signal and an odd signal? Well, this may be neither even nor odd. Can't really say anything about this signal. Okay, in general, we can't really say anything. Okay, now in the same way, you can verify a few other properties. Particularly, I'll just write even times even is even, which means the product of two even signals is even. How about odd times odd? Well, that's an even function, right? Because when I flip each of the signals, they become the negative of each other. But when I multiply them together, two negatives make a positive. So the product becomes even. So in the same way, we have an even times odd is going to be odd. Okay. Another property of even function which comes in quite handy is that when a signal is either even or odd, we can simplify the expression for integrals of even or odd functions from minus a to plus a. So let's say we have the following situation. Suppose x of t is odd, then what is integral, let's say, minus a to plus a x of t dt? Well, the interesting thing is, because the signal is odd, this integral has to be equal to 0. Why? Because what it means is, so we have a signal which is odd. When I integrate this from some minus a to plus a, the positive part and the negative part are going to add up to give you 0. So this turns out to be useful in sometimes computing integrals of things that look difficult. So for example, if I asked you, what is integral sine cubed of t dt between say minus 1 and plus 1. Now if you realize that sine cubed of t dt is an odd function, you can quickly tell me that this is equal to 0. If you actually try to evaluate the integral and then try to compute it, it is going to be quite difficult to do this, right? In the same way, if x of t is even, integral from minus a to plus a x of t dt can be written as 2 times the integral from 0 to a x of t dt. Sometimes it may be easier to evaluate the integral at the lower limit of 0 instead of minus a, and you can take advantage of this fact.